So in this video, I want to go over those questions that we did on Saturday, those ACT questions that we worked on. I want to do a complete working out of everything for you. Okay, we'll start with number 1. So like I told you on Saturday, so what you need to bear in mind is that the first thing you're looking for is a question. What is the question asking from me? Yeah, it is number 1, it says, what is the x coordinate of the midpoint? So once you find the question, then you can go find information that will allow you to answer the question properly, okay? Completely. Okay, now we have found the question. Now we're going to look for, it's asking for midpoint, right? So midpoint. All right, so we're going to draw just a little segment and put the endpoints. So we're given the endpoints. Be careful with that vocabulary. Sometimes they may give you midpoint and endpoint, but this say you're giving 2 endpoints. So here is going to be -4, comma -2 is one of the points. The other one is 14,2. Okay, so midpoint formula, sometimes it's hard to remember. So what you need to just know is that the midpoint is really the average of the x values and the average of the y values. So let me show you how that is from the formula. This is the formula. Just to show you that if you don't remember, just remember only one thing. You only remember that you are taking average. Okay, so you can see when you add 2 things together, like over here, you add 2 things together. Oops, I was going to do highlight, and it's writing over it. So x1 plus x2, this is really basically an average. Add something together, divide, so it's an average of 2 numbers. So I'm going to do average of the x values. So let's see. I do this -4 plus 14, and then divided by 2. So -4 plus 14 divided by 2 will give me 10 divided by 2, which is 5. Okay, so you don't want to waste too much time to find the y coordinate because it's not required for you to find y coordinate. If you go back to the question, it says, what is the x coordinate? So you are saving time by not finding the y coordinate. We found the x coordinate is 5, and that is the answer, 5 right there, okay? We go to the next question. Here we're given another one, but I need to go straight to the question. What's the question asking me to do? What are the coordinates of the other endpoint? Notice that it's not asking you to find the midpoint, but it's asking you to find the coordinate of an end point, not a midpoint. Be careful. So here is one endpoint is going to be given to you here. Okay, so one endpoint has this coordinate, so I'm going to write it there, 5, -8. And then watch it. You're going to say the midpoint of the segment is the coordinate is here. So you're going to give you the coordinate of the midpoint. So be careful with that. Now, we don't know what's the endpoint going to be. We don't know. So let's call it some x, y. We don't know what it is. Some x, y, that we don't know. So we're still going to use the average though. Watch. We're going to use the average. We have a 5 for x and an x for the other one, okay? Let's just call it x2 so that we cannot, we can be clear that we're using, So we're given the x to start and the x2 we don't know. So we do the average. So 5 plus x2 divided by 2. Guess what that's going to be? That is supposed to be the same answer for the x coordinate of the midpoint. So it must be equal to 1. So -1. So now this is a simple proportional equation that we can do by cross product. Just do 5 plus x2 that we don't know equals 2 times -1. Just do multiply like that, cross multiply. 2 times negative 1 is negative 2. And then you can subtract 5 from both sides. So x2 is going to be negative 7. Now, this is ACT, so you're trying to save time. See, I don't need to go find the y coordinate, the other y2. I don't need it. You know why? Because if I look down at the answer that is given to me, I see they are all different numbers. They are not the same number. So that means if I get x equals negative 7, then obviously this is the coordinate, and I don't need to waste time to go find the other one. Okay, here is the next question. A map is laid out in the standard blah blah blah. Those are long words, so that look for the question. The question is, how long in unit is the airplane? So that means some airplane is flying, and so we are trying to trace the path on a map. Okay, it's flying from city A to city B. So that's the only important thing you need to know. So I'm going to draw that city A to city B, something like this. All right, this is city A is at 20, well, 510 is the other one, the first one, 510. So 5, 10, that is city B, and then 20, 14 is city A. If I want to find how long in unit, well, I can make this, I can complete this and make a triangle out of that, a right triangle. That tells me that I can use Pythagorean theorem. All right, because look, I have 20 over here for x. The change in x is 20 and 5, so it will be 15 right here. This place is 15 units long. If you look at the change in the y value from 10 to 14, tells me this place is 4 units long. That way I can do Pythagorean theorem now. I know I need to do c equals a squared plus b squared. C squared equals a squared plus b squared. C equals a squared plus b squared. So what you need to consider is this though, that, this is square root. Every single time you are going to use Pythagorean theorem, you don't need to write this. You don't need to write the first formula. You're wasting time. You just need to do square root of whatever is given to you over here, 15 squared, plus the square root of the other one. I mean square, the square of this and the square of this. 15 squared is 225, and then 4 squared is 16, and then when you add them together, 225 plus 16 will give you 241, and that's the square root of what you're looking for, 241. And that's your answer right there, okay? Okay, the next one, you are given a triangle. Here is a triangle here. I mean, actually, nested triangle. 2 triangles in one. Actually, 3 triangles, really. Because you have this triangle here. That is your triangle TEG. That's what we're looking for, the area. What is the area of this triangle right here? All right. To find that area, we need to know, I want to put an highlight over the big triangle. This is the big triangle, is the one highlighted in yellow. And then the little triangle is the one in blue. So if I find the area of the big triangle and subtract the area of the small triangle, I'll get the area of the one that is shaded. I'll get this one that is shaded, okay? Now, you know the formula for area of triangle is just area is half of the base times height. Now, they kind of give you some numbers that you can play around with here in a very interesting way. The base for the big triangle is 19. I don't want to do half of 19, but I can do half of the height. Half of the height is 10, so I'll do half of the height. Half of 10, and then multiply that by 19. A half of 10 is 5, and 5 times 19 is 95. That's the area of the bigger triangle. I'll do area of the smaller one. For the smaller one, I will do the same thing, half of 10. 10 is the height. And then the base is 7. And then that will be 5 times 7, which is 35. Now I'm ready to subtract the area of the smaller one, the blue one, from the yellow one. So the area we're looking for, the shaded area, is 95 minus 35. And that will give me a 60. That's a 60, and that's your answer right there. The next one, you are given like a grade already. You're given a grade. So they say, what's the distance from Eastdale to Dunford? All right, this is Eastdale. This is Dunford. I will just draw a triangle. That's from there, and then go vertically like that. This is a right triangle. All right, so let me zoom a little bit. You can see that this place is 2 units long, and the other side is 1, 2, 3, 4, 5, 6 is 6 units long. So one is 2, the other one is 6. Let's zoom back again. So I got myself a right triangle, so I can use Pythagorean theorem. And that's easy enough. I just do the square root, like I told you the previous problem. Just do the square root of 2 squared is 4, and 6 squared is 36. That way you're not wasting time. So square root of 40. In this case, it's not simplified. We just leave it alone like that. All right. Now, the next problem is about slope. You say, what is the slope? What is the slope? What is the slope? Okay, so they're given 2 points. They're given those 2 points. So we're going to use y2 minus y1 over x2 minus x1. In ACT testing condition, I am not going to write this formula down. I'm just going to apply it straight away. So this is my y2. Because writing it down is going to waste your time, okay? 7 minus 5. So I'm doing 7 minus 5. And then I'll do 4 minus negative 3. 7 minus 5 is 2. And then 4 minus 3 is 7, because negative become positive 7. So now the slope we're looking for is 2 over 7, and it's positive. And that's letter E right there. Okay, number 7. Which of these lines has undefined slope? Undefined slope will be one in which the if you go back to the formula, it will be undefined if there is the denominator is 0. If this is 0, that means there's no change from x2 to x1. So only vertical line has no change, like you're not going left or right. It's just straight line down. And that's why it's undefined for a straight line down. So the only one that's straight line down is M. No change along the x-axis. The next question says, what's the value of A in the standard XY coordinate plane that passes through, there's a line that passes through this point and this point. Okay? All right. I'm going to write them out so you can see how because that form is not showing very well. Okay, you have 6A and 5. Okay, so a line is passing through here. We're going to use the same formula here to find the slope, okay? The slope is y2 minus y1. This is y2 minus y1 divided by x2 minus x1. We're going to use that over here. So notice that this will be my x, this guy over here. Write it in another column. This is my x1, y1. This is my x2, y2. So that I can just say that the slope is 5 minus 9. This is y2 minus y1. All right, 5 minus 9. And then I will do over 6a minus 4a. All right, so we do over 6a minus 4a. 5 minus 9 is negative 4. Sorry about that. And then 6a minus 4 is 2a. That way we can just say, well, this slope, we are given a value equals to 1/3, negative 1/3 rather. So we're going to set it equal to the slope given to us because that's the slope we just found, okay? Now there's a negative on both sides. We can just as well cancel them out. This negative cancel out, become positive on both sides. And then we can now cross multiply like this, okay? So we're going to say 2a, go like this, 2a equals 12. And then divide both sides by 2, a equals 6. So the answer is D right there, okay? Here is the next one. What's the perimeter of this figure? Okay, I want to show you something that's really neat about this kind of rectangles or squares. This is square. All right, if it's a square, this is so neat. You will see that to guess, if I give you a square, let's just give you a square and call this place x and x. I want to know the diagonal of this square, okay? That means that I'm going to do Pythagorean theorem. All right, I'm going to do square of this. So the length of this diagonal will be x squared plus s squared and take square root of that, remember? So it's square root of 2x squared. And so we are going to 2s squared. All right, the s squared, we can factor it out. We can actually take the square root out. Square root of s squared, square root of 2, x square root of 2. So this is going to be x square root of 2. Okay, now what is the meaning of this? It's telling us that in any square, any square with any side at all, if I know one side, then I can find the diagonal without doing any work. Watch, I want to apply it over here. Let's say now I'm given a square like this, and I told you that this side is 8 and this must be 8. Based on this thing that we found here, this will be 8 root 2. The x is like my 8. See? The 8 is my x now. So now, let's say I give you another one. And I tell you the inside is 11 root 2. What does that tell you? It tells you this must be 11 and 11, okay? So now, this is the general knowledge that they want you to be able to transfer over in ACT to this kind of problem. Look at this problem here. It's just root 2. That means there's a 1 here, 1 root 2. That's the 1 that is missing. Based on this formula that we find, this must be 1 and 1. You don't even need to remember this formula. You just have to remember that if it's a square, then the outside is always going to be, whatever on the outside is just going to be the number that multiplies the square root. It's a quick tip that will help you be able to do this problem quick. All right, let's say you know it's 1 and 1. Now they ask what's the perimeter. Well, this is 1, 1. This must be 1 and 1. So altogether will be 4. All right, the idea is this 45, 45, 90, 45, 45, 90 triangle. You just have to memorize that it's just going to be x root 2, okay? We're going to see one later with 30, 60, 90. It's just one of those things that you memorize and you just know it. All right, let's move on to the next one. Which of the following is the graph of the equation? This one is quite easy. They're giving you the equation to be 2x. All you need to do is just move the 2x to the other side. So y equals negative 2x plus 4. Now, I'll give you a tip that will help you, not to waste time on ACT. So let's say I give you 2x plus y equals 4. If you are doing this, you are wasting too much time. Your time is wasted because you're just subtracting and then doing this. That's a waste of time, You can move things mentally in your mind like this. Why? If I give you, let's say 5x plus y equals 11. I don't need to do anything. I just move this mentally in my mind and slug it over there. So y equals negative 5x plus 11. That's how you do it so that you don't waste time. All right. So by moving things mentally in your mind, I don't need to do any work. I can just see that this slope will be a negative number straight away, because I'm moving it from left to right. It's going to be a negative number. That will allow me to eliminate anything with a positive slope. That this is gone, this is gone. All right. And then there's a plus 4 that does not change. That is the y-intercept. That eliminates this one, that eliminates this one, that gets you that. If I was going to do this problem, it would take only like 10 seconds in actual, maybe less than 10 seconds by moving this like that. So you just learn a few tricks, like not tricks, but shortcuts, smart cuts. You're not going to waste time. You're going to be able to do more on ACT, okay? Here's another one. They are looking for what is the slope. Remember the question first. What is the slope of parallel line? Okay, parallel line. So parallel to this line. So you're given another line. That's the line given to you. This line is given to you. Okay, I want you to employ the same strategy I gave you. I want to get y by itself. Watch. I want to get y by itself. Zoom in a little bit. This is the equal sign. This guy is going to come from here and go over here. So I can start writing it. It's going to be negative 2x, okay? This 2 is going to get from here to the right side, become plus 2x. And then this 3y. You know, you can actually do everything in your mind, really. But start easy like that. So you have moved everything to the other side. Now you're going to divide both sides by 3. Divide both sides by 3. So y equals negative 2x third x plus, this is 2, I'm sorry, that's 2. 2 over 3. Okay, so I'll show you how I think about it without doing, I don't need to do all this work. I know it's going to be a negative slope because this is going to go to the other side. All right, negative slope. And I'm going to eventually divide by 3. So it's going to be a negative 2/3. In my mind, that's all I write on my paper. I was going to do it. I just write only this on my paper because I already moved it mentally and I divided by 3. So I know the slope of this line is negative 2/3. The one that is parallel to it, because they are parallel, say parallel lines, the distance is the same everywhere. Distance is the same everywhere when they are parallel. That means they're the same slope. Parallel means same slope. Don't confuse them with perpendicular. With perpendicular, it will be reciprocal of it. Perpendicular will be 1 negative 1 over whatever the slope is. Okay, but this one is the same. All right, so the same means whatever I got here will be the slope I'm looking for. So that the answer is B. I spend a long time on this so that you know how to do this in your mind. You have to practice doing this kind of things in your mind. That will save you tons of time that you can use to get more credit points. Okay, here is another one. The slope of line AB is given to you. Okay, that's AB is given to you. The coordinates C and D, and given the coordinate C and D, it's given another coordinate also. Now, I need to find the slope of a line passing through these 2 points right here, okay? Let's find that slope over there of that line passing through those 2 points. All right, so if you remember what I showed you at the beginning, I don't need to do any work. Remember, this is about strategy. I just do 2 minus 6, 2 minus 6, and then over 6 minus negative 6, 6 minus negative 6. Okay, that will be negative 4 over 12. Now, if you're going to do this very, very, very fast on your ACT, you don't need to do a lot of writing. 2 minus 6, you just can put negative 4 straight away. And then 6 minus negative 6, because it's a negative following each other, it's going to be 6 plus 6 is 12. This will be the only thing you are writing down. And then you can just simplify it as negative 1 over 3. See, you don't need to waste any time by trying to write all the formula, blah, blah, blah. It's a waste of time. Now, negative 1/3 will be the slope of a line passing through C to D. So that means CD is negative 1/3. But AB is 2/3. Okay, let's see if there is any relationship between them. First of all, they are not equal, so they are not parallel, so that's out of it. They are not perpendicular because one is not a reciprocal of the other one. The reciprocal of this will have been 3/2, and then with a negative added to it. But that's not what this is. So they are not parallel, they are not perpendicular, right? They are neither parallel nor perpendicular. That's all we can say. So we're going to select C because they are neither parallel nor perpendicular. That's all we can say about it. Now, this question over here, we're not going to do it because they didn't give us enough information. I don't think there's something bad about the question number 13. When I did it, it just didn't work out well. So we're not going to spend time on it. Just skip it, okay? We're going to number 14 right here. Okay, so they give you like a tree, and then the shadow. Okay, so obviously this pole is going to cast a shadow here if the light is coming from the same direction like that to both the poles, the pole and the tree. So this pole is going to cast a shadow like that, and the tree is going to cast a smaller shadow like that. What I want you to see is the triangles. There's a triangle here, and then there's an outer triangle, a bigger one. I want to highlight it. This is a bigger triangle here. It's a bigger triangle. Okay, according to geometry, these two triangles are similar. Okay, these two triangles are similar. If they are similar, then you can form ratios with their sides. Corresponding sides will be, the ratios of corresponding sides will be equal. So like, for example, the ratio of 6 to 18, that ratio there, must be the ratio of this smaller side that we don't know, question mark, to everything. Not to 15, but to everything. Remember, it's everything. So I am going to call that small side x so that it's easier to work with x. Everything will be 15 plus x. So 15 plus x because it's added together. Okay, don't form it over 15. Okay, it's 15 plus x. So now we can solve this equation by cross multiplying. But I don't want to use, I can just simplify the 6 to 18 first. That's a trick that will help you do a more efficient job. X plus 15. I just write it with x first. So then I can cross multiply. So let's cross multiply this like this. So go over here and this one over here. So I can say 3x equals x plus 15. Then now I can subtract x from both sides. So 2x equals 15. Then I can divide both sides by 2. X equals 7.5. So this is the slope. That is the distance, 7.5. Okay. We move to this one. All right, this trapezoid. At the beginning of the class on Saturday, I showed you that a trapezoid area can be related to that of a rectangle because it has two sides, two bases. This is a base. That's one base. This is another base. You just need to take average of the two bases. Okay, because they're asking you what is the area of the trapezoid. So we need to take the average of the two bases. Okay, so let's take the average. Well, we know the first one is 10. All right, we need to know how far is this place. Okay, we can drop a little thing over here and know that this place is 10. All right, we need to know this place and this place to find the remaining part of the bigger base. But this is interesting though. Look over here. they're giving you this triangle over here. See, you can use Pythagorean theorem to find this x. Now, I can tell you that it's going to be good for you to know what is called the Pythagorean triples. Pythagorean triples. Okay, I'll tell you what they are in a moment. Okay, so if I do this by doing the actual work, I will have to do 5 squared minus 4 squared and take square root of that. 25 minus 16 and a square root of 9, which is 3. Okay, so this is called a 3, 4, 5 triangle. That's what I mean by triples. 3, 4, 5 triangle. Now, you can actually look up Pythagorean triple online, and you're going to see a bunch of numbers that will form Pythagoreans. All right, I have a few. If you Google it, if you Google this is one. Okay, this is one triple. I'll give you another triple that you can see on Google, and I'll tell you which one to memorize for the sake of your test. So 5, 12, and 13 is another one. Another one is 8, 15, and 17. All right? And then the last one you need to memorize is 7, 24, 25. 7, 24, 25. Okay, you will do yourself a big favor by saving a lot of time if you memorize these triples before you take your ACT test. Just see the pattern there. Just memorize them. 3, 4, 5. 5, 12, 13. 8, 15, 17. 7, 25, 20, 7, 24, 25. Because most of the time, they are going to give you 2 of these numbers, and the third will be missing. Like in this case now, they gave you 5, 4. And then that means 3 is missing. You don't need to do any work. Somebody who is going to save time on the test will just not do this while I'm erasing that. You know what they're going to do? They're going to come over here. As soon as they see this test, they're going to recognize that this is 3, 4, 5. 3, 4, 5. And then they put the 3 over here. So they say recognition. Now this is going to be 3 and a 3. That's a 6 plus 10. That's 16. So the second base is 16. So we don't need to do a lot of work if you know your triples, okay? So we're going to do 10 plus 16 will be 26. And then average of that divided by 2 is 13. So that means 13 is the average of the 2 bases, and 4 is the height. So times 4. See, the area for trapezoid area is really B1 plus B2 divided by 2 times height. But if you know the concept, you don't need to waste your time memorizing that. Just know the average of the 2 bases and then times the height. So that way you can save time. So 13 times 4, if you do 13 times 4 is 52. This problem can take you less than a minute if you know what you're doing with triples and then knowing that the bases are average to get one base. All right, let's move to the next one. The next one has to do with scale factor that was used to go from A, B, C, D, E to this. So now this is the image. The image has prime on them. Be careful with that. See the prime? The little thing over here is the prime. Prime. Okay, that's the image. So we're going from the original to the image. So let me highlight the original in blue. This is the original to the image because you're going to be seeing the answer. Sorry about that, it's not showing. You're going to see different answers. See the answer for You're going to have, well, let me finish and I'll show you why it's important to know you're going from the original to the image. Okay, so if you go to your figure, you can see the smaller one is your image. The original is the big one because the image has primes. It has these marks on them. It has those marks on them. All right, now I'm going to go from the bigger pentagon to the smaller pentagon. I don't need to do a lot of work. I can just choose an easy side and calculate it. Well, I don't want to do a lot of division. I can choose this side over here. The ratio of this side, I want to highlight in yellow. This side to this side. The ratio must be the same as the other ratios. So we're going from 3, here is 3. 1, 2, 3 to 1. So it's 3 to 1. It's 3 to 1. You're going from, so it's going to be 3 to 1, not 1 to 3. It's 3 to 1. All right. So 3 to 1 is 3, like 3 over 1 is 3. See, if you are gone from the small to the big, the answer would have been D. But you are going from the larger one to the smaller one, is so you're sort of like, actually I said it backwards. I need to take it backwards. You are shrinking really, so it's 1 to 3 from the image to the original. Apologize. You're shrinking, so it must be, you're shrinking from bigger one to smaller one. So you're shrinking, it'll be 1 to 3. All right. Scale factor, let me write it here for you. Scale factor is less than 1 if you are shrinking, if you compress. If you compress. There's a compression from the bigger one to the smaller one. It's a compression, so it's less than 1. So apologies for that. I was not paying attention. All right, so the answer is because you are compressing, okay? Number 17. Here is translated figure, all right? A translated figure. Again, this is the original, this is the image. So if I look over here, if you look at the description given to you for the translation, that means you're going 2 to the right and you're going 3 down. 2 to the right and 3 down. So here is, which one goes, let's zoom for each of them. Letter A. I'll pick a point like H. From H to H prime. I'm going to the left and up, so that's not correct. From H to H prime, I'm going down and right. That sort of matches what is over here. I'm going right and down. So that's why it's the answer. Going down on the Y, down by 3 and right by 2. Let's check the other one is not correct. H. Here, I'm just reflecting it. That is not correct. I'm not going that way. This is like a reflection, like across the y equals negative x. So that is not correct. So the only one that matches is this. So I don't think it's a hard problem. Number 18 is not hard either. So we're going to rotate 90 degrees clockwise on this figure. Whenever you rotate, what you're doing is like you're picking a point and turning it by 90 degrees. So let's pick a point like this point and draw a line to that place. And then imagine that we move it 90 degrees. 90 degrees clockwise. It's going to land over here. That's 90 degrees. So this is going to become like that. Let me draw it in another color. So it's going to be like that. So this point comes over here. All right, because it's 90 degree rotation, 90 degrees. All right, so we're going to look at the ones that look like this. So this point is going to come over here. And this point is going to go 90 degrees, so this place. So it's going to look like this. Okay, the only one that looks like this is this image right here. That's the correct answer right here. Now, this is another question with slope. Okay, we're going to do the fast and easy way to do this. This is another opportunity to practice this with the fast and shortcut way to do this. I'll just go straight from 7 minus 2, that's 5. And then 6 minus negative 5. Because of the minus, it's going to become 11. So there's no time to waste. All right? Tell whether the following are parallel, perpendicular, or neither. Okay? I'll do the slope like fast. 8 minus 5 is 3. 0 minus negative 1 is 1, because 0 minus negative 1, it becomes 1. Negative 7 minus 2 is negative 9. And then negative 1 minus 2 is negative 3. This negative are going to cancel out, and you're going to have 3 over 1. Okay, so the first one is 3 over 1. The second one is 3 over 1. So if they are the same, that means they are parallel. They are parallel. Okay, now we're given a graph for number 21. We are asked to find the equation. This is easy. We can do elimination by looking at the y-intercept. Y equals mx plus b. You remember this? This is the y-intercept. It's 2, okay? All right, it has to be 2. So we can actually take away this and this. The slope is positive because it's rising as you go from left to right. It's going up as you go from left to right. It has to be positive. We can eliminate A. We can eliminate D. So the only thing left for us is D. We don't need to do a lot of work. That way you are not wasting time calculating, counting, rise over run. If you want to do a rise over run, so it's 2 up and then 3 rising. So you got it the same, but you can just do by elimination. Let's see. The star, blah, 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 translated 1 unit up and then reflected over the y-axis. Okay. I zoom in. I pick point C. Here's point C. 1 unit up, we land over here. Reflection over the y-axis. This is the y-axis, okay? That means it's going to go to the other side. 1, 2, 3 to get it to the mirror. And then 1, 2, 3 to get to the other side. It's going to land over here. If I move this point C up 1 and reflect, it's going to land at 3, negative 3. These are 3, negative 3. So here is 3, negative 3. See, they gave you a bunch of things that might confuse you, but it's 3, negative 3. All right. Once I have done 1 hour of this video, I will stop so that I don't know if, I don't do more than 1 hour. Then I'll do a second part, okay? But let's keep going until another 18 minutes. All right. Here is given to you. It's a sector, okay? But you have, the sector is a part of a circle. So let's say you have a circle like a pizza. All right, piece of pizza from there. That's a sector right there, okay? There are 2 things you can do. You can find the area, or you can also find the arc length of that sector, okay? Now, the basic formula for doing this, I will teach you once. I'm going to practice it, okay? Is this. You're going to use ratio, proportion. So let's say I have a full circle, and then you have a part of the circle like this. If you know this angle, this is angle theta, and then if you know the radius, then you can always find anything you want. Like, for example, if I want to know how long is this arc, okay, I'm going to call it X. I don't know it. This is X. Now, if you compare this length of this arc to the total length, the total circumference, then I can write a ratio like this. I can say X over 2 pi r. That's the ratio. That's everything. So the little place compared to all of it must be the same angle as your theta. This angle right here compared to everything, compared to the whole 360 degree. So theta divided by 360 degree. That's the ratio you have to just know. You have to know this going into the test. So that's how to find arc length. It says the arc length, the length of this arc. You take the small one that you don't know, compare it to everything. So We don't know. This is x compared to 2 pi r. Here, our r is 1.2. So it's 2 pi times 1.2 equals, the theta is given to you as 85, divided by the 360 degrees, everything, okay? I'm going to cross multiply this. See, we're doing a lot of cross multiplying today, and a lot of cross multiplying on your ACT, and write the answer here. So cross multiply and write the answer here. So x times 360, so 360 times x equals 2 pi times 1.2 times 85. 2 pi 1.2 85. And so that x equals 2 pi times 2 pi times 1.2 times 85 divided by 360. This is where you take your calculator one time. I don't have the calculator here, but I can just tell you what I did with my calculator. Plug all this into your calculator, and number 23 you will get 1.78. That's about that. All right, number 24 is a chance for you to practice what we did with midpoint. Let's see. Point M is the coordinate. The midpoint is the midpoint, okay? So, and then there's an end point, just like we did in number 2. So you are given over here one end point. End point is 7.3, and then here is the midpoint 5.4. Be careful on how you put this on the line to help you. So point M, that's your midpoint, is 5.4. Is the midpoint of AB. That's your AB. B has a coordinate of 7.3. That's your B. Coordinates, 7.3. What are the coordinates of A? We don't know what to put here. Remember, when you are dealing with midpoint, you are taking average. So let this one be x1, y1. So I'm going to find the average of x1, and 7. That should give me 5. So I'll set it up this way again. 7 plus x1 divided by 2 should give me 5. If you follow the same way we did in number 2, so you just cross multiply. 7 plus x1 is 10. And then subtract from both sides 7. x1 is 3. The only one that has a 3 in the answer given to you is D. That's a 3 as the S coordinate, so you don't need to waste time. These are all different, okay? So the only one is 3. Don't waste too much time. So it's D. All right. Here is a problem similar to what we did on number 23. Remember on number 23 we were looking for the length of an arc. Here on number 25 we are looking for the area. Okay, area. This how many square centimeter? So we actually need the area of this sector. We're going to follow the same formula that we used. This time we're not going to say arc length, we're going to say area. So I'll call the area X. Let's call it X. Inside here is X. The area is X inside, okay? So the area divided by the overall area. The overall area for this is pi r squared. That's different from the other one that we did, circumference. This was circumference. Here we do area to area. We compare area to area. And then the given angle here is 330. That means 30 is the little one there. 30 is the little one here, 30 degrees. 30 degrees divided by 360 degrees. Then we can cross multiply and do 360x equals pi times, the radius given to us is 4.6. 4.6 times 30. This is a square. Don't forget about that. This is pi r squared times 30. And now we can divide both sides, okay? Divide both sides. by 360. When you do that, you will get 5.54 as your answer, which you put in your calculator, okay? All right, we have 10 more minutes to go here. Let's see how far we can go before we run out of time. All right, radio signal transmitted from a transmitter, blah, 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 blah. I'm looking for the question. Which of the following is the closest in area in square mile of the region of the coverage? Okay, that's the radio is transmitting from here. We're looking for the area of this circle, basically. All right. All right, to find area, we do pi r squared. You have to memorize that. That's area there. So pi times, the radius is 52. So this is a kind of straightforward question. If you put that on your calculator, you will get straight away 8,500 on my calculator. So no wasting of time. Now, number 27, we're given a equilateral triangle, okay? We have to find the area of the figure. All right, you have to remember that the area of a figure of a triangle is half of the base times the height. All right, so the base is 10, okay? Half of 10. And then what is the height? We need to put a number there. Okay, so there's a pattern. You have to know something about this kind of equilateral triangle that is split down from the top to the base there. It's going to form, originally it's a 60, 60. If you drop a line from there down, that will be a 30, and that will be a 30. Now, just like I showed you something about 45, 45, 90, I want to show you something about 30, 60, 90, okay? Let me draw a generic one over here. It's very important you know it. So let's call this 60 and let's call this 30. All right, I'm going to call the length given to me here as, let's call it as 2. That way this will be 1, okay? I don't know the height, x. Okay, so I can do the Pythagorean theorem. Because I know the hypotenuse, you know what? Yeah, let's just do it this way first. I wanted to do it by generic. Let's do generic. All right, this is x. This will be x over 2. And then this is k. I don't know the height, h. Okay, I want to do h equals the square root of x squared minus x over 2 squared. That's what you do. You subtract the square of the little one from the square of the long one of the hypotenuse. So h equals the square root of s squared minus s squared over 4 when you do this, okay? If you make the same denominator, I want to work it out over here for you to see. So make the same denominator, s squared minus s squared over 4. Multiply by 4 here, multiply by 4 here. So that will be 4s squared minus s squared over 4. That will be 3s squared over 4. Just be patient with me, okay? Now I'm going to take the square root of that. Square root of this, square root of 3x squared over 4 over square root of 4. I have to split it into 2, okay? So that will be x root 3, just like we did before, and then over 2. Okay, the point I'm trying to make is this, that you see, if I know the length of the hypotenuse, I can know the length of the short side. I can also use this formula for the length of the height. So let me clean all this place up now and write what we have discovered, or what is it that we know now. So we have a space to express it. So now, what I'm trying to show you is that if I have any generic triangle like this, and this is x, this will be x over 2. This will be x root 3 over 2. That's what I'm saying. So now, why is this important? Let me give you the reason why it's important. Let's say I gave you, this is 30, 60, 90. So this is, let's say this is 8. you will know that this will be 4. It's a half of it. And you will know that this is 8 root 3 over 2 because it's the same as the 8 over there, okay? What if I change it to 20? Then this will be 10. And then this will be 20 root 3 over 2. That's the idea. This is something you need to memorize also so that it will save you time. Let's apply it to this. See how this is going to save us time by knowing this simple thing, okay? All right. So here, see, if I was going to do this without wasting time, this is 10. Here has to be 5. And here will be 10 root 3 over 2. So now I know the height. So let's go back to working everything now like I was doing before. So will be, I know the height is 10 root 3 over 2. So base is, so half of 10 times 10 root 3 over 2. I can put this on my calculator straight away. See, and I will get, if I put this straight away on my calculator, I haven't done this before ahead of time, so it will be 5 times 10 is 50 root 3 divided by 2, which is 25 root 3. Okay, let's see what 25 root 3 is on the calculator. 25 root 3. 25 times root 3. And that is going to give me 43.3. 43.3. And that is the answer right there, 43.3. Okay, so you have to know your 45, 45, 90. You also have to know your 30, 60, 90. The relationship between them. That will save you a ton of time. All right. I think we have time for 2 more, I think. All right. Here is a trapezoid. Well, I told you before, if I'm going to find the area, find the average of the base, average. 12 plus 6 is 18. 18 divided by 2 is 9. So, and 9 times the height. Well, in this case, I don't have the height. All right, I'm looking for something to multiply the height by. So, B1 plus B2 divided by 2. 12 plus 6 is 18. Yeah, divided by 2 is 9. Okay, we got that. Now I need this height. All right. This is fun because, watch. Remember I told you that you need to memorize Pythagorean triples. That's exactly what we're going to apply over here, okay? Watch. This is 12. All of this is 12. And this is 6. This is an isosceles trapezoid. If this is 6, then this plus this have to be 6. That means this is 3. This little place is 3. If this is 3 and this is 5, you're going to recognize that this is one of the Pythagorean triple. 3, 4, 5. This has to be 4. There's nothing, no need to do anything. Just know this is 3, this is 4. So the height is 4. If you plug in that 4 there, that will be 9 times 4 is 36. So it's fast if you know your Pythagorean triple. Okay, here is one more here, number 29. So you're given area of a square. Okay, you're given a square there. If it's a square, then this is 12. This has to be 12 from here to here is 12. All right, what's the area of the shaded region? Okay, you're going to find the area of each parallelogram, one of them, and then multiply by 4 because it's 4 of them. They are given all the information you need is given to you on this one, okay? Area of a parallelogram is base times height. But you're asking, how do I know the base? How do I know from there to there? You have to consider that you are given, this length is given to you is 5. Okay, let's see. Here is given to you as 5. Okay? And now here is also 5. So the area of this is base times height. So the base is 5 and the height is 3. So area of one of the parallelogram is 15 because it's 5 times 3. Area is base times height, which is 5 times 3, which is 15. And there are 4 of